Good morning guys. All right, we're back at it again with another video. A little bit of a change of pace, and this is a project that I've been wanting to work on for quite some time now. So what we're gonna be doing is converting this chest freezer into something that is called a Keezer, otherwise known as a Kegerator, which is typically something that you take a fridge and convert it into something that dispenses draft beer or kombucha. But we're gonna be using a standard chest freezer here and converting it in such a way that we can dispense draft beer, kombucha. Hannah really wants nitro coffee as well. But for the most part, what we're gonna be doing here is we're going to be using some 2x6 lumber to create a collar that goes around it where we're going to be mounting our faucets. Also doing a collar like this allows us to basically convert the freezer and not have to drill into the freezer in any places. If you drill into it through the sides, you always run the risk of hitting any refrigerant lines or anything like that. At some point, I would really like to convert this and do it up really nice. A lot of people do Keezers like this, and they put like wood around the sides, and they have a nice countertop, and they'll have like a draft tower on top. Just to get us going, I just want to do a simple conversion here because we've already got 5 gallons of kombucha in here. And I just kind of want to get it done and get it working. And then definitely over time, as I have my shop kind of fully fitted and I can do more woodworking and metalworking, I can do something really nice for this. So I've got some of the materials here to do the conversion. So essentially what we're going to be doing is installing our own temperature controller. It's got a temperature probe and all that kind of stuff that is going to measure the inside temperature of the chest freezer. And then this is going to basically control when the freezer actually turns on. So we want to maintain a temperature around 38 Fahrenheit. And obviously a chest freezer like this is designed to freeze things, which we don't want, which is why we need to do some modifications with the temperature control. And what I'm going to do, if you want to replicate this, especially with a lot of the materials here, is I will have a link and a blog post on my website. There will be a link in the comment section and in the description box below if you want to know exactly what I'm using to do this conversion. So we're going to do a really nice clean install of the temperature control system that I think most people should be able to replicate. The system or the circuits are very, very basic and very simple. So we'll definitely go over everything in this video, including installing the collar. And I should be getting all the pressure regulators and the tanks and all that kind of stuff today. So we'll see how that also goes inside the Keezer. It's time now to jump right into it.
I apologize for not posting a video for a few weeks here. I am getting everything prepped up to start the house build. So once we start building the house, there are going to be non-stop videos coming out, and I'm really jacked for that because it's going to be a really exciting build series. But for this Keezer, first thing we got to do is take apart all the hardware here to remove the top door. So once we get that off, then we can start working on making basically the Keezer collar here. So it's just basically a piece of 2x6 that we are going to attach to the top of the chest freezer there in order to give us a place to mount our taps and to basically be able to drill through and get into the freezer without having to drill into the side of the chest freezer. Because if you do it like this, then if you ever wanted to convert this chest freezer back to a standard chest freezer and have it not be a Keezer or Kegerator, then you can certainly do that. So there's nothing too complicated about making the collar. We're just cutting some 2x6s so that we can basically screw them together, paint it up, and then attach it to the top of the Keezer. A lot of people like to miter these corners here, since at some point I am going to convert it basically finish it up really nice. I didn't really feel the need to do that. And especially when you're drilling into the ends of either 2x6s or 2x4s, you always want to pre-drill those holes first so that we don't split any of the ends there. So I'm just using some 3-inch screws to attach the collar pieces together here, and then we can put it on top of the chest freezer here and see how it is gonna fit. So there's a couple different ways that I've seen people attach collars to the top. What we're going to be doing is actually just gluing it right to the top and letting it dry overnight. And now that I've got basically the size that I want, I can go around, use my orbital sander, kind of clean it up just a little bit, clean up the drill holes. And now I'm using a little bit of wood filler here just so that we can clean up those the holes that we made for where we're drilling the pieces together. Come back in probably, I mean, that wood filler stuff dries pretty quickly, but since the holes are kind of deep, I think I let this sit for at least an hour or two, just so that it's going to be nice and solid, and then we can sand it and get it all nicely painted up with the same matte black that I did with the inside of the pump house there. And once I've got it all painted off, then we can run a bead of adhesive across the top of the chest freezer here. One thing that I found after I did this is that I needed to add actually a little bit more glue that I'm currently applying to the top of the chest freezer there. There's just, some gaps there, very small gaps, but there just wasn't enough glue just to ensure that there's strong enough adhesion between the two pieces. So I did actually end up taking this apart and then adding more glue after the fact, and then retightening everything down. So I'm just using some standard straps here to tighten everything down. There's also one other thing that I found with using these straps is that since I'm pulling basically across the top of the collar there so much with the straps, is that the pieces of 2x6 actually bowed in. So when you see in an upcoming clip, you'll see that I actually added in some pieces of 2x2. You could use 2x4, basically where those straps are, just to prevent it from wanting to basically squeeze in. But this is pretty much it. So if you wanted to basically convert this back to a standard chest freezer, then you'd be able to pry this off at some point and basically reattach everything how it would have been done originally. So that's kind of how I ended up gluing everything. Let it dry overnight just so that we make sure that that adhesive is nice and strong. I just used the standard liquid nails adhesive. I've seen people use Gorilla Glue. There's different ways of doing it. And also those little white straps that I used, they left some marks on the wood, but we're going to go around and basically resand it and then touch it up with some paint. Now I'm just running a bead of silicone. This is just standard silicone. It doesn't need to be anything special or anything like that. It's just to close up any gaps basically between the collar and the freezer itself, just to make it as efficient as possible. So we don't obviously want any air gaps. Even though this is only going to be technically a refrigerator, we still want to make it as efficient as we can. So just going around, cleaning up that caulk there, and you could possibly get the caulk kind of going as well. But just to add a little bit of extra insulation, I just got some standard 1-inch foam just from the hardware store, and we're going to place that going around the collar there and glue it into place. So we're just using, again, the same standard liquid nails and just sliding the piece of insulation into place. I actually found that the problem that I had with doing this is that, not that the insulation was bad or anything like that, but I didn't take into account there's a small lip on the lid that actually sits inside of the freezer there. So what I ended up having to do was cut off about 1 inch off the top of this insulation just to get that top lid to be able to fit on there properly. And now I'm just using my quick grips just to hold the insulation into place with some glue on the back. This doesn't need to necessarily dry overnight, but at least give it a few hours there just so that the glue has some time to settle and adhere nicely to the inside of the collar. And now with the insulation finished, I can go around and just use a sander there just to clean up any little mess ups there that I made when I was strapping it down, and just getting this nice and cleaned up so that we can go around and just touch it up with a little bit more paint. Even though, again, like I mentioned, I am going to be finishing this off nice in the future, it is good just to kind of do it up as nice as you can there. Now with either Keezer or Kegerator systems, what I've seen a lot of guys do is they install a small fan inside of it so that when the freezer kicks on and it's basically putting in some nice cool chill air into there, the fan that we're going to be installing in there will help push the air around in the freezer there, just so that it's going to be circulated and chill the kegs in there a little bit more closely. So I'm just using some 3/4 inch plywood, and I just drilled a 4-inch hole in it, which matches up nicely with the fan that I got for it. And again, when we're attaching plywood or anything like that right on the end, we got to pre-drill all of our holes first, and then I think I'm just using some 2-inch screws just to screw them together. and then just go from there. We'll get this painted up, and then we can we'll have a nice little bracket there for the fan to install in the freezer. What's nice about this fan here is that this fan runs on 120 volts. A lot of fans this size, I just remember from my computer nerd days, a lot of them run at 12 volts. And so I would typically wire something like this up inside of a computer. But a lot of these, or this fan specifically, I found on Amazon, runs on 120 volts, which is really nice because it just makes integrating everything into the system much easier rather than trying to deal with different voltages and all that kind of jazz. So we'll just get that painted up, and then we are ready to basically install the fan inside of the chest freezer. And now that I have the paint out, I can go around and just quickly basically fix up any of the any places there on the collar that I wanted to clean up. Now I did install some aluminum foil tape, which you can find in the HVAC section in a place like Home Depot or Lowe's. This aluminum foil tape I installed to clean up that top edge between the collar and the insulation. I thought that would clean things up really nice. It doesn't really provide any insulation benefit or anything like that. It just kind of cleans things up. But as you'll see in a clip in a few seconds here, I basically had to remove this and remove some of the insulation. So this is where one of the major issues, or the issue that I came into with the insulation, basically the top just didn't fit properly, just with the nature of how the lid fits on top of there. So I basically just went around, took off an inch of insulation, and then basically redid the same steps as before with the aluminum foil tape and just kind of cleaned everything up. But with a lot of these projects, you know, you can read as many blog posts and you can read or watch a number of videos on it. And it's little details like this that sometimes you have to learn on your own and you don't necessarily see in a video. So if you guys are replicating this, you want to leave that insulation. Typically, it'll probably depend on your chest freezer, but you'll want to take off about at least an inch or so, or leave at least an inch of space between the top of the collar and the insulation that you're going to be installing. Installing the insulation here is not 100% necessary. Some guys don't even install that. It will provide a little bit of extra efficiency for the entire system, but it's not entirely necessary. Now that I got that insulation removed, we can double check the lid there, and it does fit how it should be. Now these clamps here, there are some strong springs on there, so it can be very tricky just to kind of get everything kind of screwed in there. So it can be a little bit easier just to mark where you want your screws to go, get them into place, and then you can kind of push it down into there and get those screws nicely tightened up. So then at that point, you've basically just raised up your chest freezer. You've just made it significantly larger just with adding that collar there. And as you see everything come together, adding that extra height certainly makes a big difference, especially with the height of the kegs on the inside of the chest freezer. That's one thing that I've noticed, especially with the pressure regulators and all that kind of stuff. It adds a lot of extra space in there and makes this a lot easier. Now, one of the trickier parts of basically doing this conversion is getting the temperature control system done properly. So I just bought this small black PVC box, and we're just basically going to cut a hole on the one end of it that is going to fit that temperature controller nicely. And then we're basically going to be doing some electrical kind of wiring inside of this, so that basically at the end of it, all we have to do is plug in the freezer into this little device that we're making, and as well as the fan. And then there's actually going to be a wire coming out the bottom of this box that you plug directly into the wall. So I had a few comments on my Instagram about, you know, why do you have to install this? Why can't you just use the thermostat on the chest freezer? And the thermostat on the chest freezer is not going to be as precise as we really need for this kind of setup. So we really want the temperature to stay between right around 38 degrees Fahrenheit. So basically, once the chest freezer goes all the way up to 39 degrees Fahrenheit, then this will actually kick back on and cool it down. It usually typically cools it down to about 37 Fahrenheit, and then it just kind of cycles between 37 Fahrenheit and 39 Fahrenheit. So I'm just using my jigsaw here to cut out the hole for where the temperature controller is going to be going into the box there. One thing to note with using a jigsaw like this for cutting plastic is that you actually want to go really, really slow with the jigsaw. If you go really fast with it, it heats up the plastic and then it actually dries or basically cools back on itself, and it doesn't really cut very well. But you can see that's how the temperature controller is going to work into there. It's actually just pressure fitted in there. There are some little clamps that hold it in place, but it's for a much thicker box that it should go into. But just the pressure of it just being held in there was enough just to hold it into place. But that's another little thing that I found out after doing this. Now on the other side here, we want to install just like a standard outlet. We're just going to be following some of the same steps here that we did for the temperature controller side. This bit that I'm using is literally the dullest bit that I have. Definitely need to get a new one. But we just need a few holes in there, and we've got our lines marked on there for where we're going to go around with our jigsaw just to cut that hole out and get the receptacle into place. So it's always advantageous just to cut the hole a little bit smaller than you need and really see if you need to make any little adjustments to it just to get it to fit in there properly. So you can see just from the outside how it fits in there nicely. And now we can figure out how we're going to mount it on the inside there. So the nice thing with the little electrical receptacles like this is they have lots of holes and stuff, or like the brackets or the ears on the top. So we're just going to do some modifications just by bending those ears around, just so that we can get a screw that is going to go through basically the back of the receptacle into that box, just so that it's held in there quite nicely. And we just need a screw to basically go through the back of the receptacle into the plastic there. So I just used some small self-tapping screws. The self-tapping screws are actually too long, so what I needed to do was basically get the self-tapper in there, start the threads and start the hole for it, and then basically just cut off the end of the self-tapper, and then we can just basically screw it right in there. And when I do a lot of these little projects, I try to use as many materials as I have available on hand rather than always going to the store and buying. I could have gone to the store and bought a small box of shorter screws, but it's just easy enough just to, just do some small modifications there just to get it to work properly. Now, coming through the one side here is where we're going to install our power cable. That's going to be plugged directly into the wall. So we're just using a strain release connector there for our power cable. So the type of power cable that you can buy for this, you can just go to Home Depot or Lowe's, and if you go to the section where all the basically where all the extension cords are and stuff, you'll be able to find power cables that are already made for you with the ends already on it. And then you can just install that and make basically your own power cable, which is always really nice and handy when you can go ahead and do some of that. So we want more of that installation off the power cable just so that we have a little bit more room for making our connections with the wire on the inside there. So we can just stick our power cable in there and just tighten up the strain relief. And then we are looking pretty good to go here. So before we can go ahead and really wire everything up, we need to get all of our tails connected to the receptacle first. So I'm just attaching a piece of green number 12 there to the receptacle. The reason why you want to get all these connected first, obviously before you have it secured to the box, is because on a couple of these sides here, you're not going to be able to access those screws once it's screwed in there. So if we do that right now, we can get those connections made, and then we can attach the receptacle back to the box there, and then we can make the rest of our temperature control connections inside of here. So we've got a green coming off, we've got a white wire coming off for the neutral, and then a black for the hot. So now we can go ahead and reattach the outlet or the receptacle to the inside there, and we can start making our connections. So Klein has these really nice reversible multifunction little electronic screwdrivers. So it's got they've got 2 different size of slots and 2 different size of Phillips heads on there. So that's really nice, really handy for some of these small kind of details or these small little screws on the temperature controller. So now we get to do all the little fun wiring bits on the inside here. I'm not going to go into too much detail about exactly how this is wired up because there is a schematic that comes with the temperature controller, and just follow the schematic and that will really explain to you how it should be wired up. But essentially, the way that this works is that there's power coming into this box, and it is going into the charge or into the temperature controller. When the temperature probe senses that the temperature is under 38 Fahrenheit, basically it turns on the freezer. And so the freezer is turned on by it being plugged in directly into the back of this box, into that receptacle that we just installed there. It works the same basically as any type of thermostat. So that's the wiring diagram that I followed. So that should be very clear on how that needs to work. If you've just got a basic idea of how to do any type of electrical work or any kind of electronics, that's basically the schematic that you want to follow, just so that it's going to be wired up properly. And it's really not that complicated. Once you kind of break everything down and just trace everything out, just following the schematic, it can be very clear on how exactly it works. So that's the finished connection there. The only thing missing from this photo is the wires for the temperature probe. Since this is only going to be cooling, we don't need to hook up any type of heating element. If you're doing a beer fermenter, where the temperature needs to stay, say, at like 72 degrees Fahrenheit, then you'd want not only the cooling element of the refrigerator, but you'd also want a way to heat it as well. Because if the refrigerator is in a place where it gets much colder than 70 Fahrenheit, then you also want to be able to heat that as well. So now with the box mounted to the collar there, I drilled a hole on the inside there to get the temperature probe to come inside the box. So it's a nice kind of clean way of getting the temperature probe into the Keezer there, is just going through the back of that box there. So now we've got our power cable hanging down. We can also just plug in our fan and the freezer into the back of that receptacle there. If you really wanted to be nice and clean and really professional, you could have got a black receptacle. I just had a white one on hand. Now I'm drilling a hole through the back of the Keezer there. That's the power lead for the fan. And once we get the wire going through that hole there, what I did was I actually just filled it up with some caulk. Now, a much more accurate way of measuring the temperature inside of this is not necessarily measuring the air temperature, but is measuring the liquid temperature. So what I'm doing here is this temperature probe, it's totally fine to go into liquid here. So I just filled up that small Califia bottle with some water and just stuck the temperature probe in there. And then just caulk the top there just so that the water is not going to spill out or anything like that. But that's a more accurate way of figuring out what the temperature is going on inside of the Keezer, rather than just having it dangle out in the air. It's just because it's going to take more. The temperature can vary much more just with the air temperature, but the liquid temperature is going to be much more consistent. So now that we've got basically that installed, we can go ahead and install the mount for our fan. So again, the fan just plugs into the back of our temperature controller little box there that we got going on. So anytime the freezer turns on, that fan is going to turn on as well to help circulate the air and keep everything a little bit more chilled. Now what I did here, we need to install some taps on this collar here. So the taps are essentially, what dispenses the beverages, so either the kombucha or the beer. Or even the cold brew coffee. So once we've got all the holes drilled through the collar there, we can install the shank. What I did there, just so that I had a very strong backing to basically tighten up the nut on the back of the shank, is I just cut a piece of 1-inch conduit. I think it's just about an inch and an eighth thick, so that when I tighten up that nut, I'm not digging into that insulation. I'm basically it's going to be a really solid connection for the shank right to that collar there. Now that we've got all the shanks installed, we can install our taps. So these are just the standard Perlick faucets that a lot of home brewers use for their keg systems here. And obviously it's just pretty simple, and there's that little extra faucet tool that you can use to really get that faucet really nice and tight on the shank. So with this here, one thing that I realized is that our main pressure regulator, it was a little bit too high. So when I would close the lid down, it would hit the top of those gauges there. So I definitely had to make some adjustments to this to get everything kind of hooked up here and just make sure that everything worked properly. So I've got our main CO2 tank on there with a CO2 regulator, and that is going to hook up to basically our pressure, kind of like, it's almost kind of like a manifold, I guess, in a sense. And you can basically control the individual air pressures to each individual keg there. And I may need to add another manifold if we start adding more kegs in there at a later time. But just very quickly, we're just hooking up our air line, which is I forget the size of it, but it's just, these are all just very standard. I think it's 5/16, and the beverage line is 3/16. I'm not going to go into detail about beverage lines and all that kind of stuff because there's a lot more detail about that I don't really know. All right, guys, so here's a final look of the Kegerator / Keezer. So I added one faucet right here, and then a stout faucet right there, which we're using for nitro coffee. So if we come inside, you can see I've got more of the air hoses hooked up. So I've got 2 kegs of kombucha, those 2 right there. These lines are extra long because the PSI for those is much higher than you'd run a beer PSI right there. So I just got a keg of Hazy Things IPA just from Total Wine there. And then we've got a keg of cold brew coffee. But I just wanted to show you guys how it kind of looked like when it's all finished. So that's a CO2 tank. That's a 100% food grade nitrogen tank for the cold brew coffee there. So we actually have nitro coffee on tap. So I think I'll probably have to do a video specific about how to set that up because it's a little bit different than obviously just doing a simple CO2 setup. But this is it. Let's pour a couple drinks. All right, guys, time for the money shot. So this is some of Hannah's kombucha here. So you can see we got the nice carbonation up there. Oh yeah. And now for the Hazy Things IPA beer. So what I'm noticing with this line here is that I'm getting a lot of head. So what I think I gotta do is our PSI is totally fine, so our carbonation is good, but I think my line length is only around, I think it's like 8 or 9 feet or 10 feet. So I think if I increase it to maybe 14 to 16 feet, then I won't get nearly as much head when I pour. But this actually does break down quite a bit. And then we've got the nitro stout here. So we're taking cold brew coffee and making nitro coffee. So if your wife, significant other is really into nitro coffee from Starbucks, then they may want to have their own nitro tap. Look at how nice that looks. Sweet. All right, guys, so that is a wrap on the Keezer / Kegerator setup. So definitely working very well. Still kind of fine-tuning things, still learning about carbonation levels and line lengths and all that kind of stuff. So maybe in the future I can kind of go into a little bit more detail about that. And especially in the future, at some point, I actually want to brew my own beer. But for right now, I just wanted to be able to get this set up so Hannah can have her kombucha, she can have her nitro coffee, and then just in the meantime, I'll just get kegs of beer from a place like Total Wine there and do it up. Awesome, guys. Thanks so much for watching. I'll have a blog post on my website, handeeman.co, with the material list for this, as well as probably some more detailed photos as well, especially